lengthy question. Let's read patiently. Alpha and beta are distinct roots of this equation. We know what how to figure out alpha and beta. What also we know that I will know what is the sum of the roots. That's negative b by a. In this case, it's negative 1. I will also know the product of the roots c by a. In this case, again, it's negative 1. We will keep these things aside, okay? Or maybe you can just write here alpha plus beta plus 1 is 0. That is what it means, okay? Now we consider a set T which contains three elements, 1 and alpha and beta, that is two roots of this equation. Now they are looking for matrix, okay, and Ri they are defining to be sum of the elements in the ith row. That means R1 is what? Sum of the elements in the first row. R2 will be sum of the elements in the second row, like that. Similarly, Cj is sum of the elements in the jth row. That means first column sum all the elements, that would be C1. Second column sum all the elements, that would be C2, like that. Okay. Now what do we want? We want to match, okay, from list 1 to list 2 we want to match them. So what, we don't have an option, right? We have to look option by option, one by one. Let's see P. Okay, so let's look at what is P. The number of matrices with all entries in T such that, okay, now see, you want all entries from the set 1 alpha and beta only can be entries in M, such that every row elements sum up to 0 and every column also elements sum up to 0. How can I do that? So these are the only available options to you. Now let's say I want to fill the first row. How many ways I can do? Factorial 3, right? Factorial 3, that is 6 ways I can fill. Let's say I filled it in this way. So first row I can fill up in factorial 3 ways, that is 6 ways. Now once you have filled that, okay, let's say I want to fill an entry here. Now, of course, see, every column and every row should be having all the three, 1 alpha and beta. Okay, you see this? That's how the sum of every row and every column should be 0. Now this column, can you see, 1 is already there, so I cannot have 1 here. I can either have alpha or I can either have beta. So there are two ways to fill that, right? There are two ways to fill this one. Now you see, if you have filled this one, now it's like a Sudoku. Now everything else will get filled on its own, because if this is 1 and this is alpha, then this has to be beta. Now this row has beta and this column has beta, so beta should be here. What else? This should be 1. Now 1 and beta is here, so this should be alpha, and alpha and beta is 1, so this should be 1. So see, every row and every column turns out to be the 1. And how many ways did you get? 6 times 2. Okay, that's 12 ways. Okay, 12 ways you can form such a matrix. So number of matrix is 12. So this maps to 2. Now let's look at the Q option. It says that number of symmetric matrices with all entries in T such that Cj is 0 for all j. That means what you want? Your column should sum up to 0. Okay, how many ways you can fill the first column, let's say? Yes, tell me. Factorial 3 again, 3 entries, 3 numbers, right? You can do that in factorial 3 ways the first column. Let's say we did that way. Okay, there are factorial 3 ways in which you can fix the first column. Now you want to have a symmetric matrix, right? So who else is fixed? This should be alpha, right? And this should be beta. Now again, columns should sum up to 0. Okay, what do I have here? Let's say, do you want to have a 1 here? So if you have a 1, if you will have a beta here. Okay, so this should sum up to 0. But then what? Then here you should be having beta and here 1. Can you see, this is screwed? You cannot have a beta here. Okay, so you don't have an option actually. Okay, that means your everything is fixed. You have to have a beta here and you have to have a 1 here. And because of symmetry, this already have a 1 here and there should be alpha here. So that means, it means to say, if once you have fixed the first column, okay, in factorial 3 ways which you can do, everyone else is fixed. Okay, so 6 ways you can do the Q option. So let's match it. Okay, it matches to 4. Now let's look at the R option. Yes, R says that you have a skew symmetric matrix. What do you know about skew symmetric matrix? Skew symmetric means that number of that the diagonal entries are 0, first of all. Secondly, whatever elements you have here, okay, let's see what elements. Aij belongs to T for I greater than J. I greater than J means what? These entries should belong to T. Okay, I don't know which one. Let's say PQR are these entries. Okay, PQR should belong to what? PQR should belong to 1 alpha or T, 1 alpha or beta. Okay. Now skew symmetric, that means if this is p, this should be minus p, this should be q, this should be minus q, this is r, then this should be minus r. This is the kind of matrix you have. Okay, then they are saying that the solution to this equation is what? Oh, that's interesting. Okay, so one thing you can do is you can form a equation, but if you're really vigilant and you see that M is a skew symmetric matrix, you can figure out. Okay, either you can just figure out the determinant of this is zero, or you in general know determinant of a odd order skew symmetric matrix is all the time zero. You just figure out. If you don't know that, you just figure out what's the determinant here. It will come out to be zero. But better you remember that determinant of a odd order skew symmetric matrix is always zero. Now, if in an equation, okay, so you have an equation mx is equal to, let's say, whatever you have y. Now, if determinant of this is zero, that means what? Either you have no solution or you have infinitely many solutions. What do you see here? You don't have an option for no solution, right? So we will have to be clever. We just say that it should be having infinitely many solutions, okay? Because it has to be either no solution or infinitely many. Okay, let's look at the last option S. M be a matrix which all its entries in T such that, okay, every row, entry of every row should sum up to zero. What does that mean? Every row should be having one alpha and beta, right? Whichever order, we don't care. Okay, one alpha beta, every row should be having, let's say, alpha 1 beta, alpha 1 beta, like that. Every row should sum up to zero. That's all the thing we have. Okay, now what do you want? Determinant. Okay, can you get the determinant? Yes, quite obvious, right? What are you going to do? Every one row has one alpha beta, so I will do column 1 is column 1 plus column 2 plus column 3, right? In that way the first column will have all 1 plus alpha plus beta. And what do you know about that? 1 plus alpha plus beta is what? 0, right? We stated that right here. 1 plus alpha plus beta is 0. Okay, so now what do you have? The first row itself is 0, right? This is 0, this is 0, this is 0. So what's the determinant? It's 0, right? So absolute value of this determinant is 0. Absolute means modulus of that. Okay, so it's 0. So which one do we have? I think C option, right? So C option is the correct option. Nice question. See you with another one.